This is the Peer Teach video for number 1. Keep in mind as you present this problem, these principles. Your job is to create dialogue and not simply dictate the answer. Your job is to ask questions. Your job is to get your quad mates to read aloud the problem. Pester, dialogue, question, elect. I actually will be grading your peer presentations. Let me just read what 5 looks like, and the other you can take a look at. 5, you're going to show given implied freebies on the diagram, and you'll specifically outline that. You engage every member by name in the problem solving process with questions. You use precise math language and vocabulary from this unit, and you show all work. That's going to be a 5, folks. You can take a moment. I'm going to be quiet for about 15 seconds for you to read what a 3 and a 4 look like. All right, for this particular problem, let's go through this. You are given a quadrilateral, GHIJ, and number 1, you want to get these coordinates always directly on the diagram. This is 0, 7, 6, 3. Down here, that's going to be 4, negative 3, and negative 2, comma 1. You're trying to prove, your ultimate goal is trying to prove that the angle HGJ, which is angle 5, is congruent to JIH, which is angle 6. So I'm going to sweep. I'm not going to mark them congruent because I'm trying to prove it congruent, put a question mark here. There is no direct way to show those particular angles are congruent because they're not on the same stir stick. So you cannot use armpits of the Z. They're pieces of triangles. So what we're going to do first is we're going to show if the entire triangles are congruent. So this triangle is congruent to this triangle. If the entire triangles are congruent, then we can say the parts are congruent, which are the angles. That's where we're going with this. So taking a look down here, how are we, on a coordinate plane, how are we going to show that? There's 3 different ways. Let me go over this really quick. First off, I can use the distance equation to show length on those sides. I can use the distance equation here to show length. That would make that equal. And then you don't have to use the distance equation in the middle because it's reflexive. And so this would give you, you just can say it's equal because it's reflexive. This would give you distance, distance, reflexive, side, side, side. Another strategy you could use is if we show the GH and JI to be parallel using slope. If you can prove that's parallel, that would give you angles 1 and 2 congruent, and that would give you a pair of angles. Then if you use slope going this way, slope, and I want you to explain all 3, then you would get angles 4 and 3 congruent, which would give you another pair of angles, and then you have a reflexive side. So using slope twice, you show parallel lines, you could get angle, side, angle. Or I could do slope again, right here, slope to get parallel lines. And parallel lines using slope would get you angles 1 and 2 congruent. That would get you a pair of angles. Then I can also, the same segments, GH, JI, I can do distance. Distance would give me congruent sides. And then down the middle, reflexive side. And this attack would give me side angle side. Theoretically, you can do all three. Make sure you know that you can show all three. But because I want you to be able to see both distance and slope, I'm going to only explain this one problem, and this is the one you're going to explain to your teammates. Okay, but they do need to know that these other two methods are possible. All right, step number one, let's get those coordinates back on there. And this is 0, 7. H is 6, 3. I is 4, negative 3. And J is negative 2, 1. Okay, we're going to go for side, angle, side. So step number one, I'm going to show that these two sides are equal length using distance equation. So GH and JI. So for GH, I'm going to do 0 and 6. Notice how I'm physically touching the numbers and doing a direction 7 and 3. Down here, I am doing negative 2 and 4 and 1 and negative 3. Going to do the math. Excuse me, that's just negative 6 squared, which is, I keep wanting to square, it's just 36. This is going to be 4 squared, 16. So this ends up being the square root of 6 plus 6, 12, carry the 1, 52. Coming down here, negative 2 minus 4 is negative 6 squared, 36. 1 double negative makes a positive, 16. And there we go. We have proven that GH and JI are congruent using the distance equation. Now we're going to do slope of GH and JI. Slope y minus y, so now they're putting the y's on the top. Once again, we touch our numbers. That's 7 and 3, 0 and 6. And on top, y's on top, that's 1, negative 3. X is down below. Notice I'm physically touching the numbers. Get your classmates to do the same thing so they don't pick up the wrong number. This is going to be 4 over negative 6. Double negative makes a positive. 4 over negative 6. We have now proven that GH is parallel to JI, which is going to give us those angles because of alternate interior angles. JH is going to be equal to JH because of the reflexive property. So you're right up, friends. Math has meaning. You have to get the meaning on here, as well as the math. So, step number one. GH equals root 52. JI equals root 52. So GH, the segment, is congruent to JI, the segment. There is your first side. Number two. Slope of GH is 4 over negative 6. JI, 4 over negative 6. So slope equals, so slope equals slope. GH is therefore parallel to JI. Therefore, because they are parallel, you can get armpits of the Z. Therefore, angle 1 is congruent to angle 2 because alternate interior angles congruent. There's your side. Number 3 is our reflexive, so that's really easy. JI is congruent to JI because the reflexive property. JI is congruent to JI because reflexive property. There is our other side. Okay, now we can name the triangles. And the triangles we're going to name JHI triangle, IJH triangle. Finally, since triangle GHI is congruent to triangle IJH by side angle side, comma, then angle 5 is congruent to angle 6 because of corresponding parts of congruent triangles are congruent. Whole equal, parts equal.